Okay, so in this video, we're going to go through the nomenclature piece, or one of the nomenclature pieces, where if I give you a chemical equation in the form of a sentence, turning that into the appropriate written down chemical compounds and then balancing correctly. So we're going to go through this. If you are Johnny on the spot with your nomenclature, this will not be difficult. If your nomenclature skills are a little rusty, you're definitely going to want to refresh them as we go. Okay, so you may need to go back and review some nomenclature to be successful here. All right, so let's look at our first example. So in our first example, I have calcium iodide plus oxygen producing calcium oxide plus iodine. So it's very, very important as you're doing these to make sure that you are identifying the appropriate symbols and charges so that your drop and swap is correct. Because if any of these individual compounds is balanced wrong, that's the ball game. Your total equation is probably going to be balanced wrong too. If any of the component parts are wrong, then the total can't be right. So it's worth it to take your time to make sure you label all your ions above the words so that you do your drop and swap right, especially as you're first learning how to do this, to save yourself the kind of silly mistakes that we see in nomenclature. Okay, so calcium iodide, calcium Ca plus 2, iodide I minus 1, plus oxygen. It says oxygen, the element, it's by itself, so I'm just going to write O and keep moving. Produces, arrow, calcium oxide plus iodine. Okay, so I'm going to bring these down. I'm going to drop and swap them appropriately, and then I'm going to prepare to balance. So let's do it one substance at a time. First, calcium iodide, Ca plus 2, I minus 1 is going to be CaI2 plus oxygen. Oxygen's by itself. If it's by itself, what do I know about it? It's diatomic. Put my subscript 2 yields calcium oxide plus 2 minus 2. No drop and swap required, just write it down. Plus iodine. I by itself, also diatomic. Okay. So once I have that done, I've already checked my diatomics. I need to make my chart so I can take inventory. So CaIO, CaIO. So what do I have to start with? 1 calcium, 2 iodines, 2 oxygens. 1 calcium, 2 iodines, 1 oxygen. All right, so I'm good till I hit the oxygen. Normally I would say leave oxygen till last, but if everything else is balanced, I'm going to deal with that first. So 2 on the left, I need to get 2 on the right, so I'm going to put a 2 coefficient in front of the calcium oxide. That's going to change this to 2 and this to 2. Now I need to adjust for that on the right, or I'm sorry, on the left. So 2 here, I'm going to need a 2 here. Makes this 2 and makes that 4, right? Because 2 times 2. So how do I fix that on this side? A 2 here as well. That's going to make that 4. So my properly balanced equation is 2 CaI2 plus O2 yields 2 CaO plus 2I2. And in terms of type of reaction, I've got a compound and a single element making a compound and a single element, or single substance. It's diatomic, but still an element. And so this would be a single replacement. So SR is fine for single replacement. Okay, so we're going to use those same steps on the next example. Strontium sulfite plus potassium chloride produces strontium chloride plus potassium sulfite. So sulfite, polyatomic, got to make sure you have the right parts of your polyatomic here. So again, if you go through and you label everything, it's a lot less likely that we're going to make silly errors from just lack of paying attention. So let's go ahead and label everything. Strontium, Sr plus 2, sulfite, SO3 minus 2, plus potassium chloride, K plus 1, Cl minus 1, produces, that's my arrow, strontium, Sr plus 2, chlorine, Cl minus 1, plus potassium, K plus 1, and sulfite, SO3 minus 2. All right, identify all of our ions. Now we need to go through and do our drop and swap. So Sr plus 2, SO3 minus 2. I don't need to add anything. Just write it down. Sr, SO3 plus K plus 1, Cl minus 1. Good there too. KCl. Arrow. Sr plus 2, Cl minus 1. Drop and swap. SrCl2 plus K plus 1, SO3 minus 2. Drop and swap. K2SO3. All right, then in terms of balancing, I think this one most of you probably can just see by looking at it, but just in case, I'm going to write out your chart. Sr, SO3, K, Cl. Why am I writing it down as SO3 instead of S and O separately? I know someone's thinking this to themselves right now. I did it that way because the SO3 stayed together on both sides, so I can count it as one thing. I could also count it as individual elements. It wouldn't be wrong. My chart would just have to be bigger. So what I like to do is if it stays together, it stays one thing, count it as one thing. Makes your life easier. All right, take inventory. 1 strontium, 1 sulfite, 1 potassium, 1 chlorine, 1 strontium, 1 sulfite, 2 potassiums, 2 chlorines. This seems like an easy fix. 2 here, and we're good. Okay? What type of reaction is this? So compound, compound, producing compound and compound. Potassium was with the chlorine, strontium was with the sulfite. Now strontium's with the chlorine and potassium's with the sulfite. That's a double replacement reaction. Okay. All right, we're going to do one more like this, and then we'll go on to predicting products in our next video. Sulfuric acid plus sodium hydroxide yields sodium sulfate plus dihydrogen monoxide. All right, so got to remember my acid nomenclature now. This is sulfuric acid, no hydro, so I know this must be the one with the polyatomic. It's still going to start with an H+, still going to end with an AQ. And sulfuric goes back to sulfate, so SO4 minus 2 plus sodium hydroxide, Na plus 1, OH minus 1, yields sodium sulfate plus dihydrogen monoxide. Now, do I need charges here? No, this is covalent nomenclature. I just write down what it tells me. Dihydrogen monoxide, 2 hydrogens, 1 oxygen. Okay. Sometimes you will see this mixed up in here. Some places to make sure you're paying attention to this is if you have a combustion as well. There wouldn't be any charges you're dealing with in a combustion because you already know what the products are. All right, let's do our drop and swap. So H plus 1, SO4 minus 2, that's going to be H2SO4. Do not forget your AQ. Plus sodium hydroxide, plus 1 minus 1, NaOH, yields sodium sulfate. So drop and swap because the plus 1 and minus 2, Na2SO4 plus dihydrogen monoxide. Just write it down, H2O. All right, so let's do our chart. So what do I got? I've got H. I've got SO4 stayed together, so let's keep that together. Na and O. H, SO4, Na, and O. So let's take our inventory. 2 H's, 1 H, so 3 H's, 1 SO4, 1 Na, and 1 O. On this side, 2 H's, 1 SO4, 2 NAs, and 1 O. Remember, I'm counting this O as the SO4, so I wouldn't look at this and say 5. That SO4 stayed together, so I count it together. All right, so we got some work to do here. All right, let's deal with the odd and even problem first. So I have 3 and 2. I notice that I have 2 here and 1 here, so the easiest way to fix this is to put a 2 here. That way this is going to become 2 and be 4. That's also going to help me with my sodium because I had 2 over here. Now I'm going to have 2 there and 2 on my oxygen. Sorry. And then let's see the other side. So I've got 4 and 2, 1, 2, and 1. If I put a 2 here, 2 times 2 makes this 4, and 2 times 1 makes that 2. So 4, 1, 2, and 2, balanced up. All right, look at my type of reaction. So I've got compound, 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 and compound. The sodium was with the hydroxide, now it's with the sulfate, and hydrogen and hydroxide came together to make water. This is another double replacement. Okay, so obviously I didn't do every possible example you can see, but I did enough to show you the patterns you should follow. Make sure you label your ionic ions. Make sure that when you're dealing with covalent, you remember you write it down just the way it says. Still write your chart, still take your inventory, add your coefficients. Okay? You just have to make sure that you do this part right first, because if this part and this part are not correct, the balancing is going to be a nightmare. Okay, good luck.